Hi everybody, welcome to another video in pre-calculus section 11.2 arithmetic sequence. So arithmetic sequence may be defined recursively as the first term is equal to a. We really don't need to know that, don't have special formula for that, and a sub n is equal, subtract a sub n minus 1 equal to d, meaning that the difference between the consecutive terms are constant. For example, if we talk about this, nine minus 7 is 2, 7 minus 5 is 2, 5 minus 3 is 2, and so on. So the difference between consecutive terms is a constant. If that is the case, we have an arithmetic sequence, and that number d, the difference between consecutive terms, is called the common difference. We really don't need to know the first term though. Yeah. Right. So next, determine the following sequence if it is arithmetic. Right. So if we have the formula 5n plus 8, so let's use the few values for n. Let's just use the calculator instead. Once again, hit mode. Make sure that is in the sequence mode. And then we'll just enter y equal to, let's start with the first term is 1, and we have 5n plus 8. And then just go to the table. The first term is 13. And then 18, 23, 28, and 33, and so on. By the look of this, look like we're gonna add 5 every time we go from this term to the next. So that is an arithmetic sequence because we just add 5 to go to the next. If we want to be sure about that, we can prove that a sub n plus n of n is equal to 5 n plus 8. If we use n minus 1, it's going to be 5 of n minus 1 plus 8. Multiply them out, 5n minus 5 plus 8. Or we have 5n plus 3. So this is a sub n minus 1, and this is a sub n. If we subtract consecutive terms, so we use the formula instead of look at the individual terms. I have 5n plus 8 minus 5n plus 3, and we have 5n plus 8 minus 5n minus 3, and that gives us 5. Since that is the constant independent of n, so this is an arithmetic sequence. So the first one, we can say yes, it is arithmetic sequence because there's a constant difference between consecutive terms. Right, the next one, let's say to go from this to the next, plus 2 here, 2 here, and then 1. So because there are no common difference between the terms, this one increased just by 1. So this is not an arithmetic sequence. Arithmetic sequence. Right. So earlier we have the formula, which is the recursive formula for arithmetic sequence. We can define an n term formula is going to be the first term plus n minus 1d. The formula is easy to determine. If we have the first term to go to the second term, of course the first term plus a difference. The next one, so to go to this one, we just add a difference to it, And the next one, we also add a d to it. Add a d to it, we have a1 plus 2d. And then we add a common difference of d, and that a1 plus 3d, and then so on. So note that this is the first term, there's no d. Second term, there's 1. Third term, there's 2. Fourth term, there's 3. So there's always 1 less times the difference. So think about this. You start this point. How many steps you need to take to go from the first to the fourth? 1, 2, and 3 steps to go from the first term to the fourth term. Take 3 steps. So always take n minus 1 less step to go from n, the first term, to n term. Alright. Let's look at this example. Find the n term and the 20th term for that. So first, we look at this sequence. To get from this term to the next, we're going to need to add 5. So we have the common difference is 5, and the first term is -1. So the formula for the general n, or the n term, is this, and we have a sub n equal to a1 is -1 plus n minus 1 times d, which is 5, which we can multiply them out. 5n minus 5, or we can say 5n minus 6. So the first time we put 1 in here, we have 5 minus 6, which is -1, which is good. So that is the formula for a sub n. Now at n equal to 20, we have the 20th term by just putting 20 into it. 100 minus 6 is 94. That's simple enough, right? Next, we have a sequence. To get from this term to the next, we need to add 3 to it. And so we have the common difference is 3, and the first term is 5. Of course, we have 38 term. We start from the first term and plus 37 step to go from the first to the 38. But I just find the formula for a sub n first. A sub n equal to a1. The first term is 5. And then n minus 1 times the common difference of 3. Multiply them out. n plus 2. And now if we want the 30th term, just want to put 38 minus 1 times 3. So it will take 1 less than 38 step, which is 37 step, to go from the first to the 30th term. And so we have 5. Of course, we're just going to put the 38 here, which is perfectly fine. 5 plus 37 times 3, 116. Right. Simple enough. Right. Next, let's say we have the A term is 8 and the 20th term is 44. Find the first term and the common difference. So how do we do that? Well, at least we know the formula for a sub n is equal to a1 a sub 1 plus n minus 1 times d, right? We don't know the difference. We don't know the common difference. We don't know the first term, but we know a sub a is equal to 8 and a of 20 is equal to 44. So meaning that when n equal to 8, the sequence is equal to 8. So 8 equal to a1. I don't know what it is. N minus 1. Don't know what n is. Oh, actually we do know n is equal to 8. So it's going to be n minus 1. Common difference, we don't know. We know n is 8, right? That's what we have. So we will have the equation a1 plus 7d is equal to 8, right? So the first term plus 7 steps to get to the a term. Now next we have a of 20, a of 20 equal to 44, a 20th is equal to 44. So 44 is equal to the first term, we don't know, but we know there are 20 terms. It is the 20th term. To rewrite this, we have a sub 1 plus 19d equal to 44. Now, if we can use the method, the reduced row echelon form, the same method that we used to solve the system of equation that we did in that section about partial fraction, section 10.5. But this is simple enough. What we can say is, why don't we just subtract side by side? a1 minus a1 cancel out. 7 minus 19, that's minus 12. And 8 minus 44 is 36. Negative 36. Right, so divide by negative 12 on both sides, so d is equal to negative 36 over negative 12 is equal to 3, so d is 3. The common difference is 3. Now the rest is simple. If we know d is 3, we can put it back in here. a1 plus 7 times 3 is equal to 8. Right? Substitute that into there. And 21 plus 8 move to the other side. So a1 is equal to negative 29. 21. Negative 21 plus 8, negative 29. Right. Of course, we can check negative 29 plus 7 times 3. Good thing we check, right? 8 minus 21 is minus 13. Right. Right. For some reason, the recording software crashed, so I have to start from the middle again. So we have the common difference is 3, and the first term is negative 13. I'm just substituting that formula, and we have a sub n equal to a sub 1, 3. Negative 13 for a sub 1 plus n minus 1 times the common difference of 3. Right? So we have a sub n equal to negative 13 plus 3n minus 3. So that is 3n minus 16. So the general term is a sub n equal to 3n minus 16. Of course, now we can check one more times. Put 8 in here. 3 times 8, 24 minus 16 is 8, which is good. Now we put 20 in here. 60 minus 16 is 44, so which is good. So yeah, that's good. Right. Next, find the sum of the first n terms of an arithmetic sequence. Alright, so this is the classic problem, so we have to go over this. So the story is this. Gauss was a student, I think it was about 10 years old, let's say. And in the elementary school back in the day, of course, it's just like now, the student kind of run chaos, and then so the teacher just give them some busy work and ask them to add from 1 to 100. But Gauss only do that in a few minutes. So what he did was, he said if s is 1 plus 2 plus 3 on the way to 100, if I write that backward, the sum is still the same, right? Have 2 times the sum. But 1 plus 100 is 101. Now you add in column. And obviously we have how many from 1 to 100? There are 100 of them, and there are 100 of the 101. So we have 2 times s is equal to 100. 101 times 100 and divide by 2. So s equal to 101 times 100 divided by 2, which is 50, 50. Right. So that is the motivation for that. So what we do is we're going to take the number of terms, divide by 2, and then the first plus the last term. The first plus the n term. So that's exactly the formulas that he did. Of course, if we write h of n equal to n minus a1 plus n minus 1d, and then we can just substitute. Here we have a1 plus n minus 1d. A1 and A1 make it 2, and then still n minus 1 times d. So we can use either formula. But the n over 2 times the first plus the n term, that is more common. Easy to memorize. Right, find the sum of the first. Once again, we have to know how many terms we're talking about here. Let's say 30 terms. Right. So how do we do that? So first, in this sequence, we can just let's say n equal to 1. It's going to be 5. N equal to 2, 7. N equal to 3, 2 times 3, 6, and 3 is 9. And n equal to 30th, n equal to 30, 63. Right? So in this is arithmetic sequence, we have the first term is going to be equal to 5 when n equal to 1. The common difference is going to be 2, and we know the 30th term, when we put 30 in here, it's going to be 63. Now the sum of the first 30 terms, I just say s of 30, or in general, the sum of the first n term equal to n over 2 a1 plus h of n. So now we have 30 terms. The first term is 3. The n term is the 8 of 30 is 63. So we have 15. 30 divided by 2 and 66. 15 times 66, 990. Right, that's simple enough. Right, next. So if we know the first term and the end term, which is good, but we do need to know how many terms is it. So let's find the sum of 51 all the way to 84. So we know the first term, we know the end term, we just don't know how many terms there is. So we know 84, let that be the end term, right? And in this sequence, what do we know is the first term is 51. To get from this to the next, we're going to plus 3 to it. So in general, a sub n equal to a sub 1 plus n minus 1 times the common difference. A sub n, we don't know what n is, but we know that is going to be 84. The first term we know is 51, and then n minus 1. We still don't know n, but we do know the difference is 3, right? Multiplying out 51 plus 3n minus 3, and 51 minus 3 is 48. So 84 equal to 48 plus 3n. So 3n, 84 minus 48 divided by 3. 84 minus 48 is 36. So n is equal to 12. Right, we have n, we have the first term, we have the common difference, we have the end term is 84. Pretty much we have everything. We can find the sum easily, right? Before I check 51, 33, yes, that's one. Right, s of n is equal to n divided by 2, a1 plus an. Right, now we want the sum of the first 12 terms. The first term is 51, and the end term is 84. So we have that, which is 6 times whatever that is. 51 plus 84, 135 times 6 and 10. So that's pretty simple, straightforward. If we know the first term, we know the end term, and we know how many terms there are in the sequence, and that gives us the sum. Right, then we have an application here. A ceramic tile floor is designed in the shape of a trapezoid like this, 25 feet wide at the base and 15 feet wide at the top. The tile measure 12 by 12 inches are placed so that each successive row contains one fewer tile than the preceding row. So we have the tile here. How many tiles will there be required? So this is what we have. The bottom row is 25 feet and a tile is 12 by 12, meaning that 12 by 12 inches is also 1 foot. So 1 foot by 1 foot, and then 25. So the bottom row we have 25. Tiles. All right. And each successive row contains one fewer than the preceding row. So the previous one is one less than that. It's going to be 24. And the next one is one less than that. And the top measure 15, so it will require 15 tiles. So pretty much we're going to have 15 plus 16, 17, all the way to 25. Right, once again, we know the first term, we know the common difference. we just don't know the term, how many terms there are in the row, how many rows there are. So we have a sub n equal to n minus a sub 1 plus n minus 1 times d. Right, a sub n we know is 25. We do know the first term is 15. We don't know how many terms there is, so n minus 1 still there. D is 1. So 25 equal to 15 plus n minus 1. N minus 1 is 15 minus 1 is 14. 25 equal to 14 plus n. So n is equal to 25 minus 14, which is 11. So it requires 11 rows of tiles. And finally, s sub n is n over 2 a1 plus a sub n. So s, now we want the sum of the first 11 terms. The first term is 15. The n term is 25. So that is 40 divided by 2 is 20 times 11. 20 times 11, 220. That's 40. Cancel out, that gives us 20 times 11, 220. Because if we want to do this, we just say the summation n of x is fine from actually we're going to add from what? From 15 to 25, and we're going to add all of the x. That's 220. Right. So pretty much what we learned in this section is arithmetic sequence. So there will be a common difference to get from this term to the next. All we need to do is the first term and how to get from this to the next. With that, we can generate the whole sequence. Right. And the formula for the n term. And if we come up from the first term to the n term, that is the formula for the sum of the first n terms. I prefer to use this one. And as long as we know the first term and the n term and how many terms in the sequence, we can just use that and we find the sum of the first n terms in the sequence. Right, this is a very short session, so I'm going to stop the video here. As always, thank you for watching and see you in another video in Calculus.